Hello guys! So this is our third crash course video dito sa Organic Chem. And I hope na dahil nanonood na kayo ng video na to, tapos na kayo sa crash course 1 and 2 and you already have answered PT 1 and 2. Because after finishing this video, after reading all of your notes and chapters sa books natin, you will be ready to answer PT 3. Okay? So guys, pakita ko yung topics natin for this crash course video. So for this crash course video, our chapter is on alkanes and cycloalkanes. So guys, 3 out of 10. Okay, so if you finish this, sorry, 3 down and 7 more to go. Okay, kasama pa pala yung biochem, no? So 12 pa. All right. So guys, here's the chapter of alkanes and cycloalkanes. The subtopics are as follows: sources and uses, physical properties, structure, conformations of alkanes, and we will also discuss specifically conformations of cyclohexane and reactions. Okay, so let's begin, guys, with the first subtopic, sources and uses. Now, guys, alam natin na ang important sources ng alkanes ay ang natural gas and petroleum. Natural gas is the chief source of methane. Also, meron din guys few amounts of other hydrocarbons like ethane, propane, butane that are present in natural gas. On the other hand naman guys, ang petroleum ay complex mixture ng organic compounds, mostly of alkanes and other hydrocarbon atoms. Together guys, we call natural gas and petroleum as fossil fuels because they were formed millions of years ago because of the degradation of animal and plant matter. Now, in this diagram, you will see guys, na ito ay pinapakita nito ang petroleum refining, the fractions you can obtain via distillation, the intermediates, and their final products. So we already know the relationship of the boiling points, of course, and their fractions. So hindi naman ito guys yung first time na nakakita kayo malamang ng diagram about refining. Okay, so actually guys, meron akong ipapanood sa inyo na video no from YouTube. Said it's sa GC natin yung link. So you would also appreciate yung different fractions from crude petroleum. So of course, they can be separated into different fractions via fractional distillation. Okay, so I'm gonna send it very soon sa GC natin. Alright, so ayan guys, so you would see na nasa top ng unit, upper portion ng distillation unit dito, ang mga low boiling components which are of course natural gas with some propane and butane, and then yung uses nila, light naphtha, heavy naphtha, we have kerosene, diesel, heavy gas oil, fuel oil, or asphalt. Okay, so ayan guys ang iba't ibang fractions from distillation of crude petroleum. Okay, next, about physical properties, may na-mention rin tayo kanina guys, yung relationship ng number of carbon atoms with boiling point yung kanina. Ngayon naman guys, isama naman natin yung melting point. So you would see guys the pattern, no? As the number of carbons increase, nag-increase din guys ang melting point and boiling point. Of course, you will think that hydrocarbons will only contain London dispersion forces, or here's organic chem, we call it van der Waals forces. So as we go along, okay, as we proceed this diagram, nag-increase yung boiling points and melting points nila because of their increasing number of carbon atoms. In fact, guys, yung mga compounds or yung mga alkenes na konti lang yung carbon atoms, they behave as gases. So these are methane, ethane, propane, and butane. So we know them to exist naturally as gases. And then we have here from C5 to C17, actually, they behave as liquids. And those alkanes na above 18 carbons na, they behave as solids. So of course, guys, factor dito yung increasing surface area, increasing molecular weight. That's why they go from gases to liquids and solids. Okay, so tandaan yan guys ha. Ito yung kanilang physical properties. Ito yung physical states nila, okay, with respect to their number of carbon atoms. Of course, ayan, so ito yung isa pang way guys para ipakita sa inyo yung sinasabi natin kanina na increasing yung surface area. So we have here space filling models of methane, ethane, propane, and butane. Yung models guys na pinapakita ko sa inyo, we call this ball and stick model. Ito nang nasa slide guys, ang tawag naman dyan ay space filling model. So we have here their boiling point values in Kelvin. So as we have said no from the previous slide a while ago, as the number of carbons increases, their boiling point also increase. And the factor here, of course, is the increase in surface area, which will, of course, have an effect on the strength, okay, of their van der Waals forces. Kaya nag-increase ang boiling point nila. Later, guys, we will introduce the concept of branching, okay, where we have the same number, we have the same, sorry, we have the same number of carbon atoms. However, pwede magkaroon, guys, ng branching. So I hope you remember in the other Crash Course video, no, wherein I explained to you about constitutional isomers. So these two compounds, these two alkanes you see here, guys, ay examples ng constitutional isomers. Let's count how many number of carbon atoms. 1, 2, 3, 4, 5. So ito ay pentane. Itong dalawa guys ay isomers ng pentane. At the left, you have the straight chain. At the right, you have the branch. Now, nag-drawing din ako guys ng another molecule to serve as our reference point para mapaliwanag ko sa inyo yung ibig sabihin ng surface area. So you can see guys na ito, okay, the branch form wherein there's a degree of branching, the surface area was decreased. Okay? Thus, as you can see guys, the boiling point also decreased. So always remember that guys. So the degree of branching has something to do with its surface area as well. Not only the number of carbon atoms, but also the degree of branching. Okay, so may effect din yan guys sa boiling point. So I hope guys, via the drawings I made here, you will be able to understand kung bakit may effect ang degree of branching sa surface area and of course sa boiling point. Okay, so ayan guys. Now, let's recall about classification or types of carbon and hydrogen. Sa previous Crash Course video guys, na-mention ko na yung primary, secondary, tertiary, and quaternary. So we will explain here sa part na to. So a primary carbon also has primary hydrogens. It's wherein, guys, it's only attached to one R group. In organic chem po, Ma'am Mitch, ano po ibig sabihin ng R group? R group could be any group attached to the carbon of interest. Most of the time, guys, yung R, ang ibig sabihin natin dyan ay alkyl group. Okay? But in general, it could be any group. A secondary carbon, on the other hand, has also secondary hydrogens and two R groups attached to it. A tertiary carbon has one hydrogen attached to it and 3 R groups. Ang quaternary carbon, guys, 4 na R groups ang attached sa kanya with no hydrogens. That's why we only have primary, secondary, and tertiary hydrogens. Okay, so very important to guys, itong classification na to until we reach the last topic. Okay, kasi dito rin nakasalalay guys yung classification nung iba pang compound classes. Okay, so this is very, very important. Okay, now, we move on to how to draw alkanes. Kasi when you know how to draw alkanes, later on, you can extend this knowledge in drawing other compounds. So you already have seen a while ago the ball and stick model, tapos yung space filling model, and then in the previous Crash Course video, you have seen the 3D way of drawing. Even yung Fisher projections, guys, na ginagamit natin for carbons that are chiral, or we call them stereogenic centers. So for example, guys, methane, this is its Lewis structure, ethane, ito ang kanyang Lewis structure, and then this is how we draw using wedges. Diba? I have explained before, guys, that when we use wedges, we also try to draw the 3D representation o yung paraan para maging three-dimensional, guys, yung appearance ng hydrocarbon or ng organic compound. Okay? And ayan nga, yung pinapakita ko sa inyo parati, guys, we call this the ball and stick model. Okay? So these are different ways to represent or to draw alkanes. All right? So now, let's look into the structure of straight chain alkane. So ito, ilang carbons meron to? 1, 2, 3, 4. C4H10. This is the skeletal structure. and of course, the condensed structure. Actually, may i-condense pa yan, di ba? Pero for now, enough na yung ganyan ka-condense for us. And then here, guys, we have 5 carbons. This is pentane, C5H12. So ito ang iba't ibang paraan, guys, para makapag-drawing or makapag-represent ng mga straight chain alkanes. We can use the model, we can use skeletal structure, we can use the molecular formula or the condensed formula. Okay? Or condensed structure. So, madali lang, di ba? Straight chain, yung mga yan, butane and pentane. However, since we already learned branching a while ago, let's imagine, guys, paano magiging branch tong mga to. Ma'am Mitch, ba't hindi kayo nag-start sa methane? Siyempre, guys, walang iba branch yung methane, ethane, di ba? At saka propane. But, if you reach C4, butane onwards, ayan guys, meron ng branching na possible. So, for the branch version of C4H10, guys, this is the branch version. Kumbaga, ito, tsaka yung butane that you have seen a while ago, they are constitutional isomers. So, ayan guys. So, if you want, we can classify yung mga carbons nila. O, game ha? Para meron tayong, para try natin guys if we still know how to classify the different types of carbons and hydrogens. So ito guys, yan, yung mga CH3 groups na yan, they are all equivalent. They are all equal and primary. Okay, so primary lahat yan. And of course, itong nasa gitna, o diba, that carbon has 1 hydrogen and that is classified as tertiary. So ito siya guys, ba't ba ako lumalayo? Ito nga pala. Diba? Carbon, 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 carbon. So you can see guys, yung tinutukoy ko, yan. So yung mga primary carbons and hydrogens. And this one is our tertiary. Okay, together with the tertiary hydrogen. Now we move on to C5H12. A while ago, you have seen pentane, the straight chain form, but it can also be like this. O yan, di ba? So meron tayong 3D model and this one. Yan naman ang kanyang 3D model. So, classify din natin guys ha. So let me erase the previous one. So this is, so Ma'am Mitch, paano po pinapangalanan pala yung mga yan? O sige guys, since we're already done with naming, di ba? So this is 1, 2, 3. So guys, the name of this compound na may ang formula ay C4H10 din. This is 2 methyl propane. O one word din na, 2-methyl propane. Okay. Next, how about this one? 1, 2, 3, 4. So the parent is butane. The name of this compound is 2-methyl butane. Okay. So pasensya na guys sa handwriting ha, nagmamadali. Okay. Another, this is 1, 2, 3. So propane, and then we have methyl groups. 2,2-dimethyl propane. So the names guys na pinapakita ko sa inyo or na binigay ko sa inyo, this is following the numbering, diba? The numbering that we did back dun sa chapter ng nomenclature. Of course, they also have other names. Yung other version, you can use yung common name nila wherein you're gonna use iso, tert, ganyan. If you remember guys, possible din yung mga yun, valid names din sila. So let me erase now yung sulat ko and let's now move on dun sa classification. So guys, here for C5H12 compounds, no, itong una muna, itong 2-methylbutane, yeah guys, yung dalawang yan, pareho silang primary. And they are equivalent. Okay, since they're attached to the same carbon. Ma'am Mitch, ito diba primary din? However, it's not the same with the 2 methyls here. Okay? Guys, ito naman ay secondary and this one is tertiary. O, diba? So, ito nga, yan. So, itong dalawa, guys, pareho lang yan. They are equivalent. However, yung nandito sa yung carbon 4, hindi nila katulad because they are attached to different carbons. Adjacent sila sa magkaibang carbon. On the other hand naman, guys, may erase naman. Ito, yung ating 2,2-dimethyl propane. So, we have 1, 2, 3, 4. Here, you can also see that they are alike. They are equivalent. They are all primary. And guys, ayan, for the first time, meron tayong quaternary carbon. So it's attached to 4 R groups, no hydrogens. Okay? So ayan guys, ang branching that we have seen in C4H10 and C5H12. Syempre, you have to practice, di ba? You have to practice determining how many branch versions, how many branch forms are there for a particular alkane or hydrocarbon. So guys, this is sample problem 16. Ayan. So we have this table from McMurray, which tells us about the number of constitutional isomers for each formula. So hindi na guys kasama yung unang dalawa kanina. So we have here C6H13. Ang number guys ng constitutional isomers niya 5. O, di ba? Madali lang. We can readily answer this one. Now I'm gonna give you the question or the problem. Draw all isomers. 5 lang naman. For the alkane, C6H14. So I'm gonna give you guys the first one, which is hexane, the straight chain form. You may pause the video, guys, if you want to answer the other four isomers. Okay? O be honest ha. So pause this video, then guys, i-play nyo siya ulit if you want to know kung tama yung mga drawings ninyo. As an added practice, you also identify the types of carbons or hydrogens and give their names as well. Okay? So pause ha, pause the video, return guys when you're ready to check your answer. So let's say guys, nakapag-pause na kayo ha. Tapos na-play nyo na ulit, eto na. So let's now reveal the other four isomers. Then, so ayan guys, answer natin na. So let's just give the name to check kung tama yung mga ginawa ninyo. So 1, 2, 3, 4, 5. This is 2-methyl pentane. Okay, so ano ang classification? This and this, they are equivalent primary. Ito guys ay secondary pero hindi sila equivalent ha. They're two different secondary carbons. Then this one is tertiary and this one, yung other terminal carbon natin, primary din. But not the same as the other primary kanina. Okay? Guys, ito namang next. So this is 1, 2, 3, 4, 5. Another pentane, branch pentane kasi sa carbon 3 may methyl group. So 3-methyl pentane. Ayan. If you will see guys, this one is symmetrical. Diba? So ma'am, ibig sabihin ba niyan, yung carbon 1 tsaka 5 the same? Yes, both are primary. Carbon 2 and 4 the same, both are secondary. And we have here a tertiary carbon bearing a methyl group na primary. No, diba? So hindi siya yung primary carbon na to guys, hindi siya katulad ng other carbons kanina na primary din. Okay, moving on. Our fourth answer. Tama ba? Oo, pang-apat na answer guys natin to. Uy, symmetrical din. So you would see guys, meron siyang plane of symmetry, which means that all of this are the same or equivalent primary and both of this are also the same. Yung tertiary carbons na yan. So this compound, pangalanan guys natin, 1, 2, 3, 4, 2, 3 dimethyl butane. Alright? So guys, ito naman. So this is 1, 2, 3, 4 o butane. So this is 2, 2 dimethyl butane. And guys, ito. So all of these are primary carbons that are equivalent. And then ito primary din, pero hindi siya equivalent ng unang tatlo. This is secondary and this is quaternary. No, diba? So guys, madali lang ang pagdetermine ng types ng carbons or hydrogens nila. And of course, you can also practice your nomenclature skills here. Now, if you also want to try the other hydrocarbons or the other alkanes, guys, you have the next one, C7H16 having 9 constitutional isomers, then followed by 18, 35, 75. O pag medyo bored guys, try nyo to ha. So itong C15, 4,347 isomers. Grabe no? C20, 366,000. And of course, ito na, 4 billion. Itong C30. Okay? So if you have time guys, you can practice yung drawing skills ninyo. Okay? So let's now move on to this. Okay, so another subtopic to guys. So far, we're finished with sources and uses, physical properties, at saka structure. Now we move on sa part na to. Ayan. So para makatulong guys, meron din akong same version ng drawing siya. What I would like to point out here guys is about rotation. Free rotation is possible around carbon-carbon single bonds. So you see guys, ang ginagawa ko, di ba? O yung kabila naman. So indeed, if there's a carbon-carbon single bond guys, kung single bonds lang ang nagdudugtong sa carbon atoms natin, possible ang free rotation. And what about free rotation, Ma'am Mitch? Ano po magiging result nito? Okay? The result is different types of conformations. Sorry, na-mute ko guys sa sarili ko. Sorry. Ayan. So different arrangements. The conformations are different arrangements that result from bond rotation. Molecules that have different arrangements are called conformational isomers or conformers. So ma'am, yung pag-ikot pala na yan, magkakaroon pala ng different arrangements pa. Exactly. And specifically, yung tawag sa kanila guys, conformational isomers or pinaikli pa siya as conformers. Okay? And we also have here, ito. So baka kasi isipin natin, ay baka katulad din ng constitutional isomers na talagang magkaiba. No. Unlike constitutional isomers, different conformers often can't be isolated because they interconvert too rapidly. So it's kind of impossible, guys, to separate different conformers. Okay? Kasi result lang naman sila ng rotation around carbon-carbon single bonds, unlike constitutional isomers na totally different compounds talaga sila because they are the result of different attachments, diba, of the atoms. So now, let's look at how we represent conformations or conformational isomers. So ito guys, ang dalawang paraan. We have the Sawhorse representation and Newman projection. Pag Sawhorse guys, ang idea is that you look at an oblique side and you draw kung ano yung nakikita mo na arrangement. O let's say staggered. So paano ang staggered? So sa point of view ko guys ha, okay, ito. Ito ang, hindi pala kita, ayan. So sa point of view ko, sige. Let's try guys na ipakita sa inyo ng mas malinaw. Okay, medyo ano ba? Paano kaya sa point of view ninyo? Ayan. So I think guys, so this could be your point of view, no? At pero kailangan kasi medyo oblique. Ayan, so parang diagonal nyo siyang titingnan. So point of view ko guys, ayan, this is a staggered arrangement. So try natin sa point of view ninyo. Paano naman po yung eclipse? Pag eclipse guys, ibig sabihin, as in sobrang, makikita ninyo na, uy, parang pantay na pantay. Okay, so you would see guys na nagko-correspond yung mga atoms when you have an eclipse conformation. So medyo hindi na kasi guys super straight yung mga bonds no ng model ko because I try to make single bonds, double bonds from these structures, yung mga bonds na yan. Okay, so ayan. So I hope guys nakatulong yon somehow. So let's go back dito sa figures na nasa manual natin. So that's how you draw a Sawhorse projection or representation. You almost look at an oblique side. On the other hand, guys, pag Newman yung projection na ginagamit ninyo, you look straight dun sa carbon single bond of interest. So for ethane, so you look straight sa carbon 1, sa carbon 2. So nakikita nyo guys, may bilog na. Kaya yung nasa harap, that's your carbon 1. Yung nasa likod, okay, so we represent it as a circle. Yun yung carbon 2. So staggered, you would see guys, the angle is 60 degrees. Okay, tama ba? Try nga natin guys. So ito ang staggered conformation sa point of view ko, yes. So there's a 60-degree angle that I can see. Okay? However, if it's eclipse, yan, magko-correspond ha, mukhang pantay na pantay guys. Then you will see guys, the angle is 0 degrees. Ayan. So I hope guys, okay, with the use of these drawings and of course, a model like this, we will appreciate yung angle na 60 at 0 degrees from staggered to eclipse. Okay, so ayan, ang ating first example guys is for ethane. So you would see here the different rotations. O diba? You start at eclipse of 0, then you rotate 60 degrees. You rotate 60 degrees. Okay, that's 120 na. Okay, and you rotate again, that's 180. So let's look at the diagram. Okay, now, yun nga lang guys, meron tayong tinatawag na torsional strain. Ma'am, kailan po yun? Diba guys, meron tayong eclipsing arrangement, diba? So there's the presence of torsional strain, which is an increase in energy caused by eclipsing interactions because they are too close to one another. So here is the diagram that we can form energy versus their dihedral angle. That's the angle I'm talking about a while ago. So ito guys, yung eclipse, staggered eclipse staggered na, arrangement nila. Okay, so ganun pala yun, ma'am. Yung eclipse, higher yung energy. Exactly. Okay, that's the increase in energy brought about by eclipsing interactions or the bonds being close to one another. Staggered, mababa. Actually, zero yung energy niya dito, guys. So, 60 degrees, 180 degrees are the staggered arrangements or staggered conformations for ethane. Now, mag-add naman tayo, guys, ng another methyl group. We look at propane. So, here's the rotations, guys, for propane. Ang nangyari lang, guys, dyan actually ay yung isang hydrogen group, papalitan niya ng methyl group. Diba? So, 1, 2, 3. So, yung drawing kanina, instead of having all hydrogens, you replace one hydrogen with a methyl group. So, paano yun mas malaki? Exactly. Bigger. Siyempre yung methyl, diba? As compared to a hydrogen atom only. So, same lang, guys, then. Almost the same yung graph natin. So, we have here eclipse, staggered eclipse. So, ganun ulit, eclipse, higher yung energy as compared to staggered. So you will already conclude na staggered arrangement yung pinaka-stable. Okay, based sa dalawang graphs natin for ethane and propane. Now, para makapunta naman tayo, guys, ng butane, you replace another one hydrogen with methyl group. Ayan. So, mamang dami. Well, there are several drawings here because two of the substituents o yung parang substituent na sa drawing ninyo sa Newman ay magiging dalawang methyl. And of course, guys, kung kanina hindi masyado complicated kung isang methyl lang, ngayon complicated na because the two methyls are big groups, diba? And when they are close to one another, magkakaroon, guys, syempre na eclipsing interactions. And you will find na mas varied yung conformations here in butane. So, let's take a look at the eclipse muna, guys. Ma'am Mitch, ba't ganon? Parang yung eclipse natin dito, merong mas mataas yung energy. Where can we find that rotation? Yung rotation or arrangement, guys, na magkalapit yung methyl group. So you see here, ito, guys, so ito. Yan, this one. Diba? So this one, ito yung, ang label na, guys, sa figure natin ngayon, totally eclipse. Totally eclipse. So parang yung kanta, no? So total eclipse yung dalawang methyl groups na ang angle ay 0 degrees. Okay, may pinakamataas na energy. Ito yung least stable among all conformations that we have here. Tapos, yung eclipse naman, guys, ito yung, kumbaga, lesser yung energy ng eclipse lang yung label. So we have here, angle is 120 degrees. Okay, erase ko yung sulat ko, ha, para di magulo. And then we have here, guys, staggered. Yung staggered natin, may staggered na may konting amount ng energy, pero ang tawag natin, guys, dito ay gauche. Okay, in the gauche conformation, the methyl groups are 60 degrees apart. Okay, so yun ang gauche conformation. And yung staggered, guys, na lowest ang energy, ang tawag natin anti, wherein the two methyl groups are 180 degrees apart. O, diba? So, mas naging complicated ngayon sa conformations ng butane brought about by the two big methyl groups. Okay, so we have the terms gauche and anti to represent the staggered conformations. Yung eclipse naman, meron tayong simple eclipse, diba? Eclipse lang at saka totally eclipse. Alright? So now, let's look at, once again, guys, ang arrangements or conformation ng butane. Diba a while ago we have torsional strain, wherein it's the increase in energy due to eclipsing interactions. Ito naman, guys, sa totally eclipse conformation ng butane, there is steric strain, increase in energy resulting when atoms are forced too close to one another. So, pinakamababa ang stability or pinakamataas ang energy ng totally eclipse conformation. And it's due to steric strain because atoms are forced too close to one another. Sobrang magkalapit. Ayun. Obvious naman, guys, sa figures natin dito. So we have here the 3D representation, ball and stick model, and space filling model. And they all say the same thing, the presence of steric strain. In another way of saying it, may steric hindrance. Okay? Next is about cycloalkanes naman, guys. So before ko pakita sa inyo yung conformations nila, let me first remind you about naming. Kasi, guys, similar lang to sa naming na alam natin. Just add the word cyclo because a ring is present. Okay, so ito guys. So practice muna tayo sa naming ng cycloalkanes. Then after this, I'll show you naman the slide on conformations. So the first one guys, we have an ethyl group. The name is ethyl cyclobutane. Take note, no number is needed since there's only one substituent. On the other hand guys, for the cyclohexane that we have here, there are two substituents. So there's a need for numbering. Okay, you may pause the video, then return if you want to, or play if you want to know the correct answer. Ang pangalan guys ng second cycloalkane natin dito ay yan. Ma'am, bakit po 1-sec-butyl? Ito guys, so itong group na to ay secondary butyl group. Okay? So, ang number 1 siya guys. Number 2 ito, number 3. So as you can see, nauna yung sec-butyl. Ma'am, akala ko ba yung sec gagamitin yung S? Hindi guys. We use the B. Okay? So if you remember, iso, yung iso lang yung kasama dun sa alphabetical, but sec, tert, even guys yung di, tried, we don't include them sa pag-alphabetize. Okay? So assign the lower number to the first substituent alphabetically B of butyl before the M of methyl. Kasi baka pagbalik ta rin nyo, baka gawin ninyong 1-methyl, 3-sec-butyl. No, it's the other way around. We use B of butyl. So kaya siya 1-sec-butyl, 3-methyl cyclohexane. So ito guys, I hope you remember, diba meron tayong part dun sa alkyl groups wherein in-explain natin yung pinanggalingan ng propyl, isopropyl, ng butyl, isobutyl, sec-butyl, at saka ng tert-butyl group. So this one, itong connection guys ng butyl group dito sa cyclohexane ay through the secondary carbon. Okay, so ayan guys. Next is this compound. So you will see guys, meron tayong plane of symmetry. O, diba? So this is a symmetrical compound, and carbon 1 at 2 na guys, automatic yung dalawang methyl groups na yan. So the name is 1,2-dimethyl cyclohexane. Another compound na symmetrical din. O, diba? Actually, pati yung ethyl ethyl cyclobutane guys, ano din siya, symmetrical. Ito lang yung hindi symmetrical, yung second compound natin. So you have here 1, okay, carbon 1 ang isa dyan. So paano po numbering yan? Ayan guys, 1, 2, 3, 4, 5. Pag nag-start ka naman dito, pag nag-start tayo guys na magkatabi, so that's one way to do it. However, kung naalala nyo guys, dapat lowest possible numbers. So erase natin. Kung mag-start naman tayo dito, 1, 2, 3, 4, 5. O, diba? So mas mababa yung possible numbers niya. The correct answer guys, 1, 2, 4, triethyl cyclopentane. So a while ago, 'di ba? Nag-try tayo guys kanina nung mag-number kayo dito. Of course, you have to consider yung other guidelines pa sa naming. So you can change your numbering. You can try, okay? Try and try until makuha ninyo yung set of locants, set of numbers with the lowest possible number. So it's 1, 2, 4, not 1, 3, 4, and not 1, 3, 5. Okay? So I hope guys, we're done. Nakuha ninyo, no, kung paano ang naming ng cycloalkane. So I hope this is clear now because we would like to move on to conformations na. So ito guys, ang maliit, no, 'di ba? Lowest, smallest. Ito ang smallest natin na cycloalkane, which is cyclopropane. Alam niyo ba guys, yung way ng pagde-describe sa bonds ng cyclopropane is that meron daw siyang banana bonds kung saan almost bent, 'di ba, yung mga bonds. Ma'am, bakit? Guys, there's a very high angle strain here in cyclopropane. Why? 'Di ba ang sp3 guys na hybridization nagre-require ng tetrahedral angle with a value of 109.5 degrees. And you will see dahil triangle ang figure or ang shape ng cyclopropane, 60 degrees lang na napakalayo sa actual angle na 109.5 degrees. As a result, very unstable guys ang cyclopropane. It prefers reactions na nag-ring opening to lessen. O, diba? Para ma-lessen yung kanyang angle strain. Alright? So, ayan guys ang kwento ng cyclopropane. So, you will find na ito ay very prone to ring opening reactions. So, ayan, nabanggit ko na yung angle strain. It's the increase in energy when tetrahedral bond angles deviate from the optimum angle of 109.5. Napakalayo guys ng difference, no? 60 degrees sa loob, where in fact dapat 109.5 ang value. Okay, next. Ito guys, cyclobutane strained pa rin, cyclopentane strained pa rin, and cycloheptane guys ay hindi din kasing stable ng cycloalkane na pag-uusapan natin. So ito guys, ang other cycloalkanes pa, at yung kanilang 3D way of representing it. Kasi ang gusto kong i-point out guys sa inyo, yung optimum na formula ng cycloalkane na hindi kasing strained ng mga nakita ninyo. Guys, ito ang cyclohexane. So we have here different ways on how to draw it. Pwede rin guys ang Newman dito. Ayan, yun nga lang, you need two Newman circles. And then of course, yung kanyang ball and stick model. So, i-reveal ko rin naman guys sa inyo kung anong tawag sa conformation na yan. Okay? So, let's look at this figure. Ito yung conformational analysis guys ng cyclohexane. So, we will see here guys na ang may pinakamababang energy ay ang chair conformations. So, you might ask, ma'am, bakit po dalawa? Because it will undergo ring flipping, which I will explain later. And then we have here guys, twist. Okay, and then both conformation, baka familiar kayo, and ang pinaka-unstable, the highest energy belongs to the half-chair conformations. Okay, so explore natin guys yung pinaka-stable na conformation ng cyclohexane. Now you might wonder, Ma'am Mitch, bakit nagpo-focus tayo sa cyclohexane? Kasi guys, ang mga substituted na cyclohexanes, ang pinaka-common na cycloalkane. So ito yung nararapat na gawin nating representative no ng mga cycloalkanes, and of course, okay, may kakaibang stability meron ang cyclohexane. Kung bakit, let's look at the next slide. Ayan, di ba? So I'm lucky to have this picture wherein we can find both chair and both conformation. So bakit siya chair? Mukha ba talaga siyang chair? In this figure guys, kung saan may girl sa picture, you would appreciate, makikita ninyo kung bakit nga siya tinawag na chair. Actually, it resembles a lounge chair. Okay? So let me read this. Cyclohexane adopts a strain-free, so wala itong torsional strain, walang angle strain. It adopts a strain-free three-dimensional shape that is called a chair conformation because of its similarity to a lounge chair with the back, seat, at saka footrest. No, diba? So yan guys, ang tinatawag natin na chair conformation. So ito ang pinaka-stable na conformation for cyclohexane. Okay? So ito nga, sabi natin kanina, chair cyclohexane has neither angle strain nor torsional strain. All carbon-carbon bond angles are near the 109.5 degree tetrahedral value, and all neighboring carbon-hydrogen bonds are staggered. In drawing chair cyclohexane, guys, ganito, kailangan nyo i-consider ang dalawang positions which are axial and equatorial. Kaya axial equatorial is because we have an axis and of course the equator. So on each carbon, guys, meron tayong dalawang hydrogens. One is axial, the other one is equatorial. Ano pa, kailangan nyo tandaan, may up-down tayo. So meron tayong axial up, meron tayong axial down, meron tayong equatorial up, equatorial down. So paano pa pag magdodrawing ng isomers? Let's say we want to express cis and trans isomers. Pag cis, guys, same side. Pag trans, opposite. Ibig sabihin ng same side, up, up, down, down. Kapag opposite naman guys, up, down, or down, up. Okay, so always remember this when you are drawing cyclohexane na naka-chair conformation. Okay, so let's try nga guys. Try natin na. So draw the chair conformations for cis 1,4-dimethyl cyclohexane. Sige, mag-drawing tayo guys. Pili lang ako ng black na color. So mas madali guys mag-drawing ng chair kung nasa board tayo. So aminado naman ako sa board, mas madali. Actually, mas gusto ko sa blackboard. Okay, promise guys. Para sa akin, ang ayos, pinakamaayos ng drawing ko ng chair conformation pag nasa blackboard. Hindi ganun kaayos pag nasa whiteboard, lalo na guys dito, mas challenging dito sa tab using this drawing tablet, no? But I'm gonna try my best guys para makipakita sa inyo ang cis 1,4-dimethyl cyclohexane na naka-share. Okay, so let's try guys. Actually, if you will read books, may may discussion sila on how to draw at share confirmation. O, pwede na. So, pwede na guys yung drawing na to ha. Mamaya naman, mayroon dyan figure na mas maganda, yung galing sa Smith. So, cis 1, 4, ibig sabihin guys, same side. So, let's say ito, no? Ito ang eggshell, isang eggshell na methyl natin siya. 1, 2, so straight line guys to ha. Bond talaga yan na maayos. Okay, then this is number 2, number 3, number 4. So, cis, so ito ay naka-up. So, this is equatorial up. So, on each carbon, let me remind you guys, you have both eggshell and equatorial positions. One up, one is down. So, yan guys, ang figure natin for cis-1,4 dimethyl cyclohexane. But take note guys, nag-undergo kasi ito ng ring flipping. So let me erase my figure, my drawing, and show you the figure na meron sa book natin sa Smith. So ayan, kamukha naman ng drawing ko kanina, di ba? So ito guys, some eggshell up, okay, naka-emphasize, and of course, equatorial up. So Mitch, ba't may nakalagay na 50%? Again, as I've told you guys, it's an equilibrium with its yung confirmation 2 after ring flipping. So hindi ko siya ma-demonstrate guys kasi hindi ito yung model na kailangan to demonstrate ring flipping. Unfortunately, wala ako ng model na yun guys kung saan ma-demonstrate ka sa inyo yung ring flipping. Okay? So this is confirmation 2 and you will see na yung eggshell up natin na methyl, it's already equatorial up. Up pa rin naman. Pero nag-change ng position to equatorial. So this is our carbon 1 a while ago and this is our carbon 4 na nag-eggshell up na ngayon. Okay? So with respect to these two conformers, as you can see guys, 50-50 because each conformation has one methyl group in the eggshell and the one equatorial position. They are identical in energy. At room temperature, therefore, these two conformers exist in a 50-50 or 1:1 mixture at equilibrium. Okay? So yan guys, ang cis-1,4 dimethyl cyclohexane. So 50-50. Kasi if you were to ask me, which one po ang more stable? Pareho sila guys. Pantay na pantay kasi sila ng percentage. As you can see, parehong tig-isa ng isang eggshell at tig-isa na equatorial. Ma'am, paano kung gawin nating trans? Okay, game. Gawin natin trans, guys. O, ayan na, meron na akong tanong dito na, meron na akong statement dito na label the more stable confirmation. So, let's try again mag-draw, guys, ng chair. Tapos, gagawin naman nating trans. So, this is our methyl. Pasensya na guys, mahirap mag-drawing ng straight bond sa tablet. 1, 2, 3. O, dapat trans. So, 1 should be down. Ayan. So, ano kaya ang stable? O guys, if this will flip, okay, magre-ring flip yung conformer na yan, then you will imagine na, edi ma'am yung dalawang eggshell nagiging dalawang equatorial. Exactly. Okay? So, we were, again, to choose guys, we will choose the more stable conformation. So, ito yung drawing natin kanina, wherein two methyl groups are in the eggshell position. And nakalagay dito, more crowded eggshell position. Meaning guys, may mga kalapit kasi guys na hydrogens, no? If the two methyl groups will be in the eggshell position, hindi nga lang pinapakita sa drawing, but it will be somehow in the crowded position. Okay? And then you will see guys, equilibrium arrows na mas favored yung equatorial position. The di-equatorial conformation is the more stable conformation because of the absence of the di-eggshell interactions. Meron kasing ganun guys. If you want to know more about this, you read McMurray or Smith. Okay, yung sinasabi ko na di-eggshell interaction. So, always remember guys, more stable ang equatorial position. So in this case, for trans-1,4 dimethyl cyclohexane, more stable conformer yung dalawang methyl groups na naka-equatorial conformation. Okay? So, hindi naman 50-50, hindi na. So, the conformation with equatorial position is the more stable one. Okay? So, ayan guys, ang sample problem number 18. Okay? Now, we move on to sample problem number 19, naming. O, diba? Since meron na tayong cis-trans a while ago, let's apply it to other compounds. So, here guys, ayan. So, gusto ko i-emphasize sa inyo na yung bold wedges, this will tell you na mas malapit sa'yo, no? Yung kumbaga out of the paper siya. And then yung wedges naman guys na dash or hash sila yung mas malayo sa inyo. So this is one way to represent cycloalkanes in 3D way. So I hope guys, ma-appreciate niyo yung 3D way, no? So ito, these two compounds above, they are both cyclopentane. However, same side yung bromine in one of the isomer, the other one naman guys, opposite. So that's the difference between cis and trans. Okay? So ito guys, ang cis 1,2-dibromocyclopentane, the other one is trans 1,2-dibromocyclopentane. And below, we have two isomers for dimethyl cyclohexane. The first one is our cis 1,2-dimethylcyclohexane. As you can see, the methyls are on the same side. Opposite naman guys on the other one. So this is trans 1,2-dimethylcyclohexane. So cis and trans do not only apply to alkenes, which will be our next lesson. However, nag-apply din ito guys sa cycloalkanes. Diba? So always remember, cis and trans isomerism can also be seen in substituted cycloalkanes. Okay. So guys, sa last part na tayo ngayon ng video na to, which is about reactions na ina-undergo ng mga alkanes and even cycloalkanes, of course. So we will discuss two reactions. The first one is this one, combustion. The second one is halogenation. So I'm sure guys, very familiar tayo sa combustion. So let's have our general equation. Alkane reacting with oxygen to form CO2 and water. So take note guys, if this is complete combustion, so the product will be CO2 and H2O. Complete combustion will occur if there's enough amount of oxygen. So let's have an example here. This is CH4 reacting with 2 moles of oxygen to form 1 mole of CO2 and 2 moles of H2O. So guys, complete combustion, products are CO2 and H2O. So you can apply this to other alkanes or cycloalkanes. Of course, mag-undergo din guys ng combustion yung iba pang hydrocarbons. In fact, guys, sa lab, I remember this, meron kaming evap dish. Then we put a small amount of our hydrocarbon sample, then put it on top of the flame. Then we will see yung effect niya guys sa flame, no? Kung ang flame ba ay sooty, ganyan. So we also look at the quality or the type of flame na pwede mag-result sa combustion ng mga alkanes. So kapag alkanes guys, alkane yung hydrocarbon sample ninyo, then it will be medyo clean yung flame niya, no? However, if there will be unsaturation, which we will explain next time sa next lesson natin, you will find na the flame becomes sooty. Okay, so explain din natin yan next time kung ano yung nangyayari sa flame, no, during combustion. Depende guys dun sa type ng hydrocarbon sample. Okay, so this is combustion guys. The next one is about halogenation. So we will explore guys ang effect ng chlorination, syempre chlorine yung halogen natin dito, and bromination later. So chlorination muna guys. This occurs via 3 steps. Kasi ito guys, nagpo-proceed to via free radical. So the first step of halogenation in general is initiation. The second step is propagation. The third step is termination. All right? So for initiation guys, so chlorine needs the presence of light, okay, to form the radicals because the radicals will initiate the reaction. So paano yan ma'am? Drawing natin guys ha. So drawing natin yung mechanism kung paano nagbe-break yung bond between chlorine. Gagamit tayo ng green na color. Okay, kasi green yung chlorine natin even sa model. So let's say guys, ito ang bond between the 2 chlorine atoms. So the bond will break homolytically wherein each chlorine atom will have an unpaired electron. And we know that free radicals are very reactive. Now, the reaction will start na kasi initiation na guys. Nasimulan na natin. Meron na tayong free radical. So the reaction is already started. So ano mangyayari? Paano mapaparami man? Paano yung propagation step? So here is one possible propagation step. So we have here chlorine radical reacting with methane. So methane guys, so example natin ng alkane dito. So I will emphasize yung isang carbon-hydrogen bond sa methane. Wherein this will break guys, okay, and join with the unpaired election of chlorine. And then of course, one will go with the carbon. So ito ang result. So HCl plus methyl radical. Diba? Kaya nga siya propagation. Kasi once simula na guys yung formation ng radical, ano na, kagulo na to kasi very reactive nga ang mga radicals. Of course, the methyl radical is also reactive. So, pwede rin siya guys mag-react with a chlorine molecule. So, ayan. So, pagpasasya nyo na guys yung drawing natin ha. So, ayan. So, it will form this alkyl halide and of course, another chlorine radical. So, the reactions of propagation will continue and continue until guys may presence pa ng radical. The whole process will be terminated once radicals meet and form a neutral molecule. So this is one possible termination reaction, another one, another one. So ayan guys, ang 3 steps: initiation, propagation, termination for a halogenation reaction. Okay, so in this case, ang example natin, chlorine. Okay, to demonstrate yung tatlong steps na ito. So to give you the overall reaction of the several steps that occurred, ito guys. So ito ay overall reaction ng monochlorination, wherein 1 mole of chlorine reacted with 1 mole of methane to form the chloro. Okay, the chloro substituted alkane and of course HCl. So yan guys ang overall reaction. Now guys, sa manual natin, pinakita ko dito yung rate of hydrogen abstraction because there are different types of hydrogen. Meron tayong primary, secondary, tertiary. And you will see here guys na pinaka mataas ang rate of abstraction ng tertiary hydrogen. 5 yung rate niya. 5 times kumpara sa primary hydrogen na 1 lang yung given na rate. So it means that guys na kapag tertiary kasi this forms a more stable intermediate. So don't worry, when we reach the next chapter, mauunawaan nyo kung bakit yung tertiary yung mas stable na intermediate. Okay? So ayan guys, ang chlorination. So ibig sabihin ba niyan ma'am, yung products po ng chlorination ay pwedeng mixture? Exactly. Since possible guys na mag-react ang lahat ng types ng hydrogen na pwedeng i-abstract from an alkane. So yung primary, secondary, and tertiary. However, mas mataas ang chance na mag-react yung tertiary. Okay? So ito guys, meron tayo ditong sample problem pero hindi ito about chlorine. Okay? Baka isipin nyo, hala, baka chlorination yung question. So you have here guys sa manual again ha, yung rate of abstraction. Okay? May sinabi pala ako dito. Less energy is required to break a tertiary carbon-hydrogen bond. Thus, the resulting radical, the tertiary radical is more stable or form faster. Okay? So, this statement, guys, we reiterate natin to, mauulit natin to when we reach the chapter on alkenes. Okay? So, let's have our last sample problem here in this video. Which of the following alkanes will react readily with bromine? Okay? So, ayan guys. Ito ang ating mga choices. So, ayan muna. Bromine muna bago yung choices. Ma'am, bakit? I want guys to reiterate na mas useful ang bromine sa lab. Alam nyo kung bakit? Kasi ito guys, it exists as a liquid. So, in contrast with the other halogens, ang chlorine gas, ang iodine naman solid, it's too slow to react because of its size. Ang bromine guys, liquid and readily observable siya sa lab. It's an orange-colored liquid and visible yung reaction. Okay, kaya sinasabi ko, let's do this guys. Pakita ko sa inyo yung mga test tubes. Teka, ayaw eh. Teka lang ha. Teka lang guys. Ayan. Okay, noong una ayaw. So here are the alkanes. So we have C5H12 down to IC8H18. So lahat naman yan guys ay mga alkanes. And ayan. So you will see guys na lahat sila ay clear and colorless na liquid. So I'm quite sure meron kayong experience guys. Baka meron kayong naalala pa from your organic lab na pwedeng similar sa experiment na gagawin natin here sa discussion natin. So we have here pentane, hexane, heptane, octane, and I8 is actually isooctane. So each test tube guys, lalagyan natin ng orange-colored liquid which is bromine. And then, we will watch closely which will react readily. Ano yung mauuna? Sino yung mauuna sa kanila guys na mag-react with bromine? Ma'am, paano? How do we know? Kasi guys, if you place bromine liquid to all of this to all of these samples, they will become orange, of course, di ba? Kasi clear and colorless naman yung sa hydrocarbon sample. So, pag lahat sila naging orange na, how do we know, ma'am, kung nag-react na po sila with bromine? Of course, guys, ang change in color, yung sign natin na nag-react. So, the orange color of bromine should somehow fade or unti-unting mawawala. And that's a sign that bromine already reacted with the hydrocarbon in the test tube. Okay, so para maunawaan yung sinasabi ko, let's watch this video. So, ayan sila guys ha. 5, 6, 7, 8, I8. For positive control, there's bromine liquid. So let's just wait for a bit before guys magkakaroon ng visible sign of reaction. Ayan. So guys, mamarkahan natin na. So nakikita nyo ba yung nangyayari ngayon sa test tube na to? It becomes light orange. Ayan, it becomes light orange, guys. And eventually, mahuhulaan nyo, guys, na magiging clear and colorless na yan later on. Okay, so let's stop right there. It's almost clear and colorless. Anong test tube yun? That was a test tube of I8 or iso-octane. Okay, so drawing natin, guys, ha? Drawing natin yung structures nila. So straight chain alkanes lang naman ang C5, C6, C7, tsaka C8. However, yung iso-octane, guys, yung pinaka nag-react. So, ma'am, yun na ba yung answer? Yes. Yung pinaka nag-react na mabilis ay iso-octane. Why? Because meron siyang type ng hydrogen, guys, na wala yung ibang hydrocarbon samples natin. So, we could see, guys, na, so meron yung primary, lahat naman sila may primary, secondary. However, eto yung wala sila, yung ibang hydrocarbons, the presence of the tertiary carbon-hydrogen bond, which, okay, of course, we have explained a while ago, will react the fastest. Okay, as compared sa primary at secondary. So yung kanina guys, na pinaliwanag natin, it does not apply only to chlorine, but also to other halogens. Okay, wherein mas reactive yung tertiary carbon-hydrogen bond. Okay, yun nga lang, ginamit natin yung bromine ngayon kasi you have seen guys sa video kanina, sa video clip kanina na mas madaling gamitin sa lab ang bromine. Yung reactions ay madaling ma-observe. Okay, it's easy to handle kasi bromine is liquid and yun nga, visible. Okay, very visible guys, yung positive sign of reaction. So iso-octane having the tertiary carbon-hydrogen bond reacted fastest as compared to other hydrocarbons. So we will be using bromine again guys when we reach the topic of alkenes and alkynes kasi it's commonly used as a test reagent. Okay, so ayan guys, ang last part ng discussion natin here, ng lecture natin here for alkanes and cycloalkanes, which is the reaction part. Okay, so let me now wrap up itong lesson na to guys. Tapos na tayo sa alkanes and cycloalkanes. So after watching this video, you can rewatch it again. And then of course, you can read notes. Read again your notes dito sa manual natin. Read chapters ng alkane, cycloalkane sa books natin, McMurray and Smith. Okay, kailangan guys ma-complete kasi yung knowledge ninyo again no for each chapter before you answer the practice test. It's quite dangerous or it's quite ironic guys if you will answer the practice tests without reviewing first. Kaya nga ganito yung routine natin sa review, 'di ba? Lecture or crash course muna and then you read on your own, you review on your own with all the resources, with all the materials you're provided with before you answer each practice test. And of course, may schedule tayo for the synchronous practice test discussion. So by now, guys, pang-apat na subject to, you now understand bakit ganito yung routine natin sa review. Okay? And this program works. It really works. It's just up to you guys kung susunod ba kayo properly sa schedule natin. I do hope na you are following, or kung nadadali man kayo, you are doing your best to cope up, okay, to recover doon sa mga backlogs ninyo. Okay, so bye muna guys for now. You are now to answer PT3, and do not forget to submit before our practice test discussion.